In this content, we will discuss about growth and depreciation. So we all know the topic growth and depreciation is related entirely to the compound interest. Now look at the bottle here. I have done 3 points. 1, 2, 3. First point is 200 milliliter. Second point is 300 milliliter. And the third point is 450 milliliter. Now let me draw it. First one is 200 milliliter. Second one is exactly 300 milliliter. Third one is 450 milliliter. So now, suppose in a bottle 200 milliliter water exists. Suppose a bottle having 200 milliliter of water. After a 1 hour interval, if the amount of water will increase 50% rate. I am repeating, after the 1 hour interval of each 1 hour of interval, the amount of water will increase with the rate of 50%. Then after 2 hours, what amount of water exists in the bottle? That is the question. After 2 hours, what amount of bottle will exist in that bottle? What amount of water exists in the bottle after 2 hours? Simply, what you should do? The same thing, the same formula we should apply. The formula is what? We know the rate. Rate here is what? 50%. After 1 hour interval. After 1 hour interval, someone pour 50% water of the water is exists in the bottle. So think about it. The formula we know, simple. P into 1 plus R by 100 to the power N. Right? So if it is the formula P plus 1 by R plus 100, we know what is R, what is N and what is P here. So P here is what? At the beginning we had 200 milliliter of water. So our P here 200. Then 1 plus R. What is the value of R? 50. And you have to determine after 2 hours, right? So you have to put here 2. Calculate it. 200 into 150 by 100 into 150 by 100. Isn't it? So now what will be the answer? If you cut down this 30 into 15, that means 450 milliliter. Here we have 450 milliliter. That means from 200 milliliter to 450 milliliter. From 200 milliliter to 450 milliliter, the increase rate is what? 50%. So that means from 200 to 300, it is 50% is rate of interest. Sorry, it's not rate of interest, but it's the rate of increase. Again 300 to the 450, again 50%. Right? Same thing. It is the same. The same thing is applicable when we are talking about population. Suppose 200 people lives in a small city, but every year the number of people or the population increases 50%. Then after 2 years, what will be the number of population or what will be the number of people? So after 2 years, same thing. 200 people lives, 1 plus 50 by 100. So 450 people lives now in the country after 2 years. This is the concept of, the basic concept of growth and depreciation. Yeah, it's the same thing happens when we are talking about depreciation. Suppose 450 are there. And now consider we are now here 450. So 450 milliliter. After 1 hour, think about it. After 1 hour, the amount of water will decrease at 50% rate. Exactly. After 1 hour interval, the amount of water will decrease 50% rate. Then what will be the amount of water is present after 2 hours in the bottle, right? So what we had 450. To use the formula, same formula but in minus. P into 1 minus R by 100 to the power n. Now here P is what? Your 450 into 1 minus 50 by 100 to the power 2. Why? Because after 2-hour interval, the same thing you have to determine. That is, sorry, it is a 45. I written wrong. 450. So 450 into, if you 50 by 100 into 50 by 100. So now if you consider any quantity increase for the first year exactly with the rate 25% and the second with the rate, sorry, in the second year at the rate of 40%, then what will be the exact amount or the exact quantity after 2 years? Mind it, for the first year it is 25% and for the second year it is 40%. Then what will be the exact amount or quantity after 2 years? For the first year this is 25%. For the second year it is 40%. So first of all, which formula we should use? The formula is very simple. We know 1 plus R1 by 100 into 1 plus R2 by 100, right? So if instead of increasing, if the quantity is decreasing, then we should use the minus here, right? So now what will be the case? P plus 1, P into 1 plus R1 by 100 into 1 plus R2 by 100. So we have to put 25 here, R1 and R2, right? So now consider the same scale with a different value. 400 milliliter. Then what will be in the last after 2 hours? First hour, second hour, right? If a bottle having 400 milliliter of water and then if after 1 hour someone pours 25% of the water and in the second hour if someone pours 40%, then what will be the amount of water exist after 2 hours? That is our question. Okay, so what should we do now? We simply put here 400, then 1 plus 25 by 100 into 1 plus 40 by 100. So 400 into 125 by 100 into 140 by 100. So then solve it. (28) into 25, that is exactly equals to 700 milliliter. Okay, so that means after 2 hours, after 2 hours, what we have? Milliliter. Same question can be asked in that way. If a small city having population of 400 people, then what will be the number of population after 2 years? If first year the rate of increase is 25%, second year 40%, then the same formula we should follow. If instead of increase, the decrease or decrement or depreciations are there, then we should use minus here. Okay, the same thing. So if you want to determine after 1 hour, right, so then you have to use this only. So that means what will be the after 1 hour or after 1 year? 400 into 1 plus simply 25 by 100, that is 400 into 125 by 100, that is exactly nothing but 500. Okay, so put here 500. So that means you can also look at in the scale like 400 to 500. If we want to go 500 from 400, then the actual rate of increase is nothing but 25%, right? And if we want to go 700 from 500, the actual rate of increase is 40%. That is the case. So this is a very basic content of growth and depreciation. We will move on to the typical questions.